Good afternoon, everyone. Today we're looking at energy yield in glycolysis. What is glycolysis? Glycolysis is the breakdown of glucose to pyruvate. And at the end of glycolysis, ATP is produced and NADH, which is an electron carrier, is actually produced. Glycolysis can take place in the presence or absence of oxygen. Hence, we have aerobic or anaerobic glycolysis. Aerobic glycolysis, the net ATP yield is 2,8 ATP, while anaerobic glycolysis is 2 molecules of ATP. What is that the implication? Because ATP is generated in glycolysis, what is it used for? It's actually essential for various cellular functions, and it provides an immediate source of energy. Not just an immediate source of energy, because the only form of energy the body recognizes must be in the form of ATP. So we say ATP is a currency of the cell because it can be spent. And if it can be spent, there must be a way of producing that. At the end of aerobic glycolysis, 8 molecules of ATP are produced, like as I mentioned before. And at the end of anaerobic glycolysis, we have 2 molecules of ATP, and those 2 molecules is actually 2 substrate level phosphorylation. While for the aerobic glycolysis, we have NAD, 2 molecules of NADH, which goes through oxidative phosphorylation, and then ATP is produced through the process of meiosis. How is glycolysis regulated? It's regulated using three different enzymes regulate the pathway. We have hexokinase in step 1. We have phosphofructokinase in step 3. And of course, pyruvate kinase, which is step 10. These are the enzymes that actually regulate the pathway. And what's actually the basis of regulation is based on the adenylate energy charge. And that is why it is regulated. And regulated is to ensure that the energy demands of the cell is met, and there is a prevention of excessive glucose utilization. Thank you very much. God bless.